Okay, this is video number 6 of continuing with our journey developing the code for Gyrocam. In this video, we will be enabling I2C to communicate with the BNO055, and let's think that, yeah. Um, and we will be displaying, I have a setup ready to go. We will be displaying the calibration register and its individual components for the magnetometer, acceleration, gyroscope, and the system itself. We also display the heading, pitch, and roll, and we will calibrate um, the gyroscope as well. We might not save it to memory right now. That would be for the next video. So let's get going. Let's see. So this is the same file for video number 5. I made a copy just so I could keep it the way it was. So nothing has changed. We do need to make a change for the configuration. But before we do, let me highlight something. If you get this item or this BNO, you will have to solder these 2 pins. This one came with the pins already soldered, but the one I have on my unit, it didn't have it. So if it doesn't, you will have to solder them, or you will have to write your code a little bit different. So this is required. Also, the pins are the last 2 pins is 32 and 31, the ones for I2C. So those are the ones we will enable. Those are port number 1. So let's get going. I2C, enable it. And oh no, that's not the one I wanted. Port 1. There we go. Change the speed to fast mode, 400 kilohertz, and you see that it enabled the wrong pins. We want this 2 at the top, so you can press Control and click on the pin and hold it down, and you'll see the flashing alternative pins for SDA, and if you do the same for SCL, you'll see the alternative pins. So what we do is we click on the pin itself and select I2C port 1, and you see that it disables it here, and it enables a new pin for us. This one, intake. There we go. We generate the code. Okay, so that's all we need. Now we're just gonna create the new code, and that's gonna be in its own class. So we create a class by clicking on CPP. The class will be the name of the unit, BNO055. We move the header file to INC and the CPP file to source. So let's arrange them to work with them a lot easier. And we include the main file or header to give us access to whatever it's in that file. We're also going to include a couple of headers just in case we need them, so we don't get errors. Okay. We'll need a few private variables. and some public functions. Okay. First two variables we need is one to get the handle of the device. So, and this will be a pointer because it's a handle to an actual device, and we'll call it device. We also need the device address. We'll just call it slave address. Okay. We will need to change the initializer for the class. We can add a new one, or we can change this one. Let's just change this one. And this one will need the handle as a pointer. And it will be, let's call it pdev. We also need the address as well. And we'll just call it slave. And we add a default value since it's most likely going to be 29. So we'll leave it like that. We can come back and change this function now, which will be that one. Okay, so I2C handle, it's a pointer, pdev, and then an unsigned integer, and the, what did you say, it was slave, right? Here we can assign the device to be the same as pdev, and the slave address to be the same as slave. And we shift it to the left once because these are 7-bit addresses, and we need to shift them to the left because bit number 0 is going to be utilized as a flag for reading and writing. Okay, we're done with that function. We also need a way to reset the system whenever we need to configure. So we'll add actually, we need to add two functions, one for reading, one for writing via I2C. So first function will be read register, and it will take unsigned chart, the register, signed chart, the data, let's just call it data, and the size as well. Okay, we need another one with the same signature. This one's going to be write register, so we can add him here. BNO, and we want the read register, and we said it was sign chart register data, and the size we need a variable to handle the return just in case we get errors, we get to debug it. I2C mem read. So we're going to use the first function there, and we'll use pDevice. The address will be the slave address, and the memory address will be the register, and the size is always 1. This will be data, size is size, and timeout will be 1 second. We also want to set the flag for reading. Okay. And then we return whatever we have. The next function is the same, just this one's going to be writing. So this is write, and we remove the flag since it has to be 0. Okay. Next function, or next two functions, we need a function to reset the system and another one to enable it to start getting orientation data. So first one we'll call it reset, nothing on it. The next one, enable and DOF, which means 9 degrees of freedom. Okay. Okay. Let's see. Reset, and to reset it, we go into the data sheet. Under trigger, where is it? Right here. So sys trigger. Let's see. So sys trigger, bit number 5 is for resetting the system. It's here, reset, set to reset system. So if we set this, we'll reset it. We're also gonna set 7 and 6 on a different write. This one is for using external clocks, which we are using. External clock is right here. It's supposed to make it more accurate. And we're gonna clear, or reset the status of all the integers, or of all the interrupts. So to reset the system, it's going to be address 3F. We go, actually, we need a local variable first, private variable. And we're going to call it data. It's going to have 22 bytes. The 22 bytes are because when we do calibration, it requires 22 bytes. So we set the data, the first byte. We're only going to send the first byte. So 7 and 5 zeros, and then 7, 6 zeros, and then a 1 for the 5th bit, and then the rest are zeros. So now we write the register. Was saying it was 3F. Is that what I said? That's right here. So it is 3F. The data remains data, and size will be 1. Whenever well, before we can reset the system, we need to switch the system into configuration mode. You're not allowed to write to change any settings unless you are in configuration mode. So that is just writing a 0 to a different register. See what that is. Operation mode. So this is the one. If you want to see what that is, that's on page 21, I believe. So all zeros on operation mode takes you to configuration, and then the NDOF will be bit 2 and 3, so 0, 1, 2, 3, set to 1. Also note this, switching switching from config mode to any operation mode takes 7 milliseconds, so there has to be a waiting period, or it won't work. And switching from any to config mode is 19 milliseconds. So we're switching to config mode right now. We have to wait 19 milliseconds. What was the... So we're using operation mode 3D. Okay. That's the address. Data size 1. And we have to wait 19 milliseconds. Then we reset the system. That's a reset. the reset of the system, there's a flag that you can just run a loop and check until the system is done resetting, but it takes about just over 500 milliseconds, so it'll be safe to just wait 600 milliseconds and we'll be good to go. Okay, so that's for resetting the system. The next one is for enabling the NDOF. So BNO enable, and to enable this we are changing the where is that, page 71 I believe. Okay, so this is, we used this flag before to reset it. Now we're gonna set this to 0 and this to 1. This one 7 is to enable the external clock, and 6 is to reset the interrupts. So data, and the first 2 bits equals to 1, and then the rest just zeros. Okay, so it's 3 what was it, 3D 3F is the same as this 3F. Okay, data and 1, and now we change to enable NDOF. So we change data again, and that will do it. If you remember on page 22, I think it was, or 29, this is what we're doing. We're setting the first 4 bits to 0, and then these 2 are the important ones, and then the other 2 to 0 for NDOF. That's what we're doing. Right range. This one is 3D. It's the same as this. We're switching from one configuration to another. 1, and according to this should take 7 milliseconds. So let's delay for 7 milliseconds, and we should be good to go. Last function. We want something to get data, so we'll just get data, get all the data we need. To get that data, we need a few variables. So let's start by having what we say. Let's start with heading, pitch, and roll. And we need the calibration data as well. This will be calibration data. We also need the calibration components. So we need 4 of those. Gyro and system. Okay, I believe that's it. So we have our function signature. Let's see, get data, and for this one we start by getting the calibration data first. So this time we use read register. The register we're going to read, find out what that is. Calibration data, so this 35, so it's calibration stat. Okay, so here it is. It's X35, and the first 2 bits are for the magnetometer, then accelerometer, gyroscope, and the system. So we'll get those in that order, and we'll have to get those components out of those 8 bytes. So x35 data size 1, and let's start by getting, well, first let's assign it to calibration, right? So this will be data 0, and then we can get each of the components. So we know this is first, second, third, and fourth. So yeah, that's correct. And what we're going to do with this is the calibration data, and is the first 2 bits for the magnetometer, and we need 3 more. The gyroscope, oh, gyroscope and system. Okay. Okay, so there we have it. This one we need to shift it twice, 4 times, and 6 times, and we should get each of those components. The next one is to get the Euler angles. So go back to 52 and see where those are. So we need to get from this one heading. Each of those angles are 2 bytes, so we need to read it and then do the conversion to a whole number. So it's all in sequence, so it starts with in 8-1, so that's 1 byte, 2, 3, 4, 5, and it should be 6. Here's the 6th one, so we're gonna read 6 bytes starting with 8-1, and that should give us the heading, roll, and pitch. So 1. So read and 8-1, or 1A, not 8-1, data, and we want 6 bytes. And now we need to get each of the components. So the first one is the heading, and all right, so this requires a bit of a, it's going to look a little complicated, but it's not really complicated. So we get, first we're getting the LSB, which means is the least significant bit, and then we get the most significant bits, right? So it's in the wrong order. The numbers really are the most significant bit, or the biggest number goes first, and then the second. So the first 8 bytes should go second, and the second should go first. A little confusing, but bear with me. This will be 0, this will be 1 for data. So in this one, we need data 1, but this one needs to be converted to an integer of 8 bytes. And this conversion needs to be shifted 8 bytes. So we'll end up with 16 bytes, but we need to move it to the left 8 bytes first. And then this, we can now add the first byte, right? And this number, once we have those two, now we need to convert it to a 32-bit data. And finally, we need to convert it to a double. So that should give us what we want. Let's see if we have any problems with it. We shouldn't. Actually, we do have some errors. So I think I have too many of those. So let's try this again. So we are converting to an int, right? Data 1, and once that is converted, we want to shift it 8 bytes, we can do it here. And then data 0. And this has to be converted to 32 bits. Okay. And finally, we might not need to do this, but we're gonna do it anyways. We convert it to a double. Okay. And we do the same for the other two. So we set we're getting heading then roll. So this will be roll, and this will be pitch. And we just change this so it's 0, 1, and then 2, 3, 4, and 5. And that should do it. So if we did everything correctly, we should be able to get data and see it on the phone. We should be able to see all of this components. So let's go add that code here. Okay. We also need the handle to the I2C, and that one is external. It's on the C file, and we know it's handle I2C 1. So when we define the class, let's call it gyro. We can just specify that handle. Actually, this. We're not specifying the address because we are using 29, so we're using the default. And if it compiles, we should be golden. All right, we're good. So let's display some data. So first, say gyro reset, gyro enable and DOF, and then gyro get data. Now we have the data. So we can, let's start by sending just roll for now. Okay, so just to test. Let me see. R, so it's just R. Okay, so it's going to be R colon and then the float, return gyro, and we want roll. Right? So let's see what we get. See if we're gonna get some roll data. Okay, there it is. So we see it here, but we also see it in this one here. So if we rotate it, you see it gives us the angle, right? But the angle is incorrect, so we forgot something. So in the documentation, where is it? So it says that for Euler angles, if you're getting degrees, then 1 degree equals 16 data points of the least significant byte. If you're getting radians, then it's 900. So we have to divide it by 16 because we're getting degrees. So in the code or in the class here, we say heading divided by 16, and we do the same for all three. Roll and pitch. Let's compile once again. So this is what I added. I just added those three. Okay, so now we should get an accurate angle on this one here. So, right, very responsive. So it's minus whatever degrees, and then positive degrees. Right. So let's send the rest of the data. So we need, let's just copy this. We're going to be sending heading, roll, pitch, and then we want calibration data, and we also want the magnetometer. We want the acceleration, gyro, what is the next one? So that's 1, 2. What am I missing? So magnetometer, gyro. So okay, this is system, and that should be it. So we got gyro. This is going to be heading, roll, pitch, and this one is calibration data. We may have to change that one to convert it to binary, because it's just going to be a whole number. Gyro, calibration magnetometer, gyro mag, gyro ACC, and gyro and last one, system. And let's see, we have the same number of components. If we do, okay, no errors, so let's run it. So now all of those will populate. So it's just one long string with each of the individual components. The first layer is what the phone is looking for as a field name, and then the value is the field value, and the function just adding the individual components. So let's load it. And now we'll see all of those populate, and this will be just unreadable. All right, so most of it is there. These ones are not reading for some reason. We'll see why not. Oh, because they're not floats. So all of those are not floats. That's it. Let's send it again. Okay, so we have all the components populating. If we rotate this, you can see the heading as we rotate. You can see this heading change. If we rotate this way, you can see roll and pitch. And down, you can see the calibration. It already calibrated the magnetometer and the gyroscope. Acceleration hasn't been calibrated, and system hasn't been calibrated. So we'll leave that for the next video, where we'll be able to calibrate it via the phone. We'll send the command to do the calibration for us, and then it'll save it. So the next time it powers up, it'll just load the existing calibration, and you should be able to recalibrate it whenever you want from the phone. And we'll change this so it makes more sense as opposed to a whole number. Well, hope you enjoyed this video. Till next time, enjoy.